Students, now that you understand the nature of electric charge, we move to one of the most fundamental laws in physics, Coulomb's law. This law describes how two charges interact with each other, and it is the backbone of the entire subject of electrostatics. Let us understand this with depth and clarity. 1. Statement of Coulomb's law. Coulomb's law states, the force between two-point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance between them. F is equal to q₁ q₂ R2. This elegant equation tells us how strong the electric force is between two charges. 2. Direction of force. If both charges have same sign, the force is repulsive. If they have opposite signs, the force is attractive. And very importantly, the force always lies along the straight line joining the two charges. This is extremely helpful while solving vector problems. 3. The Coulomb constant. K is equal to 1. Numerically, K 9 times 10 9 Newton meter squared per Coulomb squared. This constant works only in vacuum or air. 4. Medium and permittivity. If charges are placed in a dielectric medium, F_medium is equal to F0 R, where R is the relative permittivity. A medium with high permittivity reduces the force between charges. This concept will be extremely important later in capacitors and dielectrics. 5. Validity of Coulomb's law. Coulomb's law is exactly valid only for point charges, spherically symmetric charge distributions, where each sphere behaves like a point charge. This is a very important G concept used in shells, spheres, and charge distributions. 6. Vector form of the law. For precise problem solving, especially in G advanced, we use the vector form F_12 is equal to q₁ q₂ R2R. This tells us both magnitude and direction of the force. 7. Newton's third law compatibility. If charge 1 exerts a force on charge 2, charge 2 exerts an equal and opposite force on charge 1. This symmetry is extremely important for multi-charge systems. 8. Superposition principle. One of the most powerful principles in physics is electric forces do not interfere. The net force is simply the vector sum of all individual forces. F_net is equal to sigma F_i. This principle makes complex problems solvable. Whenever multiple charges are present, superposition is your first and most important tool. 9. Common G applications. Coulomb's law is used heavily in equilibrium of charges, charges placed at corners of polygons, force on central charge, collinear 3-charge arrangements, force ratio problems, zero force points, systems using symmetry. Nearly every G paper includes at least 2-3 problems directly or indirectly based on Coulomb's law. 10. Conceptual insight. Students often memorize the formula, but they forget the deeper truth. Coulomb's law tells us how the universe balances electric interactions with perfect symmetry and mathematical beauty. Understanding this will make later topics such as electric field, potential, dipole, and Gauss's law far easier to learn. This completes our deep understanding of Coulomb's law. With this foundation, we can now move confidently to the next topic, the electric field, the true language of electrostatic interactions.